Not here.
ข้าวหอม
It's not here yet.
Okay 1 2 3
Good
Good
afternoon, teacher.
Good afternoon, students. Welcome back. Welcome back.
Good afternoon student how are you today
I'm good.
I'm fine.
Yeah thank you
Right.
Okay the first I want to know who joined our class are you ready Yes Okay 10 absent right Okay Aidin
Present.
Thank you Asia Absent Okay Hupo Okay Ichi
คุณครูคะวันนี้ฮูโปลานะคะ
Okay Hupo and Okay Ichi Julong absent Okay ปะเลคาน
Present.
Thank you ภูผา
Present.
Thank you nephew absent เจ้านาย absent เป๊ะ Can you say present
Present.
Thank you ก้อย absent boom
Present.
Thank you grape
Present.
Thank you หยก
Present.
Thank you อุกอิก
Present.
Thank you ฟ้าใส
Present.
Thank you ไข่มุก
Present.
Thank you บัว
Present.
จีน
Present.
ใบบัว absent โอเคข้าวหอม absent โบนัส
Present.
ข้าวหอม two
Also absent.
absent โอเคหุยเล้ง
Present.
Thank
Present.
you ใบตอง
Present.
idea
Present.
Thank you ข้าวกล้อง
Present.
Thank you for student join our class Okay turn on your camera please let's go
Morning, afternoon, students. Welcome back to a new week. Hope everyone is very excited. Yay! We're going to start a new week and we're going to start it off with some mathematics. So last week we had some break and the week before that we completed triangles. So today we're going to start with polygons. Okay. We're not going to do the vocabulary now. We will do it when we are looking at the specific polygons because there's quite a few. So what is a polygon? A polygon is a shape that has straight lines and always connecting into a closed shape. So there's no gaps. So you can't have a half moon as a polygon or only two sides of an angle. It always has to close, but it can have a minimum of two sides. So a triangle is probably the first one is 3 sides. And then we go forward, we go more down up to 12 side shapes. So we get the triangle is for 3, a quadrilateral for 4, pentagon 5, hexagon 6, heptagon 7, octagon 8, nonagon 9, decagon 10, hendecagon is 11, and the dodecagon is 12. So as we will probably only look at the first 10, If I'm going to ask you questions, we will focus mainly on the first 10 because we have to also use some formulas to calculate the angle sizes. So we'll also have a look at that. But we get 6 different types of polygons, and we'll also quickly have a look at that before we practice our words here. The first one we have is you get regular or irregular polygons. You get regular or irregular polygons. Now, a regular polygons is all the sides or all the angles are the same size. So a triangle is a regular polygon, or quadrilateral is a regular polygon. All of these have the same angle sizes, are regular polygons. So an irregular polygon, for example, let me draw you a picture, would be a triangle which has different size angles, like a right triangle. Remember this one. Now the one over here, this is an irregular polygon because all the angles are not the same size. So it's irregular. If all the angles are not the same size, it is irregular. So we have also, very basically, we have a square. We can have a square or a rectangle, but we can also have something like a rhombus, which looks more like this, like it's a square turned on its side. Now this one will still be a regular polygon because the angles will still be the same. So regular, all angles same size. Irregular, not the same. Okay, the next one is the difference between a convex and a concave polygon. Ooh, some interesting words for us to practice today. We'll practice them soon. So a convex is all the angles are pointing outward and all the angles are less than 180 degrees. So if you look at all the shapes on the left-hand side here, all of these are convex polygons. All the angles, as you can see, I'll do something different here. Let me zoom in here. Now I can show you. Remove all. So if you look at the triangle over here, you can see the angle is pointing outward. It's not pointing towards the angle or the shape, it's going away. So all of these are pointing away. So how does an angle look with sides pointing, or a shape with sides pointing inwards? So a polygon always straight lines, but for example, here we can see this one is pointing inward. So the angle, the size of this angle is more than 180. But we'll look at some example in the book, also have some nice examples. So a convex is all the angles are pointing away. Sorry, are pointing away. A concave, at least one angle is pointing to the inside, which has a size larger than 180 degrees. We'll have a look at this in just a moment. And then the last two we have is the simple and complex polygons. Now a simple polygon is all of these on the left-hand side are all simple polygons. They do not cross over each other. So a complex polygon will be something that looks like this. It has a shape like this, and it maybe has a shape like this. This is called a complex polygon because it is overlapping and interchanging each other. It does cross over each other to create a shape like this one over here. So let us first do some practicing. So the first two we're not going to practice. We're going to practice the next 8 of them. Okay, so all of you must say together. After I say it, I want all of you to say it as well, so we get some practice. Are we ready? Yes. Ready? Yes. 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 Oh, you guys don't sound very ready, but here we go. Let's start. a side, a shape, or a side with 5 sides is called a pentagon. So altogether, pentagon.
Pentagon.
That sounds wonderful. Excellent, excellent. When you have 6 sides, you have a hexagon.
Hexagon.
Very good. Excellent, excellent. And for 7, it's a little bit more tricky. It's a heptagon.
Hexagon.
Hexagon.
One more time. Heptagon.
Hexagon.
Hexagon.
Oh, you guys are pronouncing it beautifully. Thank you very much. Well done so far. Okay, if we have 8 sides, we have an octagon.
Octagon.
Hexagon.
Excellent. Well done. For 9, we have a nonagon.
Nonagon.
Well done. Well done. And the last one, 10 sides, is a decagon.
Hexagon.
Excellent. Excellent. So that is a few of the shapes we're going to look at. And if you look on the right-hand side, let's quickly practice the words we don't hear that often. First one is irregular.
Regular.
Excellent, excellent. The next one is irregular.
Irregular.
Excellent. Well done, well done. And the next two at the bottom here, the one is a convex.
Convex.
At the end again, one more time, convex.
Convex.
Vex, yeah, almost. The X has a rolling, a silent rolling S at the end there. Okay. The next one we have is a concave.
Concave.
One more time, concave.
Concave.
Yes, that sounds beautiful, beautiful. Okay, so this page I have right here is very important page. You do not have this page. If you want me to send it to you, I can send it to you. Just a quick explanation of the different polygons and types of them. So let's move forward and let's have a look on page 40 of our books. We can see here a polygon over here. Straight lines, no angles in a polygon. You can't draw a polygon like this. It's not straight lines. All the lines has to be straight. So this one is not a polygon because it has an arc over here, and this arc is not straight. This one over here has straight lines, yes, but it does not close over here. So it's open, meaning it's not a polygon. So a polygon is a 2-dimensional closed shape composed of 3 or more straight lines. 3 or more straight lines. Okay. And there we have the explanation that they give us, the regular polygons versus the irregular ones. Let's have a look. All sides are equal for regular polygons. So an equilateral triangle is a regular polygon. And a right angle triangle or right triangle is a irregular polygon. So yeah, the convex, we can see all the shapes or all the sides are pointing outward. Can you see all the angles? They're all pointing towards the outside. For convex. Concave, meaning it's falling in. So there's one angle. So here we can see one angle pointing inside. One angle pointing inside. So if you have to calculate these angles, there will be more than 180. Okay. It looks like a sad face here. Be more than 180. The last one is the simple and complex polygons. So the top over here is the simple ones. There's no lines crossing over each other. But here you can see the lines crossing here and here. Make it complex. We can see crosses over here. We can see over here, over here. So all of these crosses in the shape means it is more complex. Also, the calculations are not as easy. We have to have a little bit of knowledge to do the calculations. Okay. So those are 6 different types of polygons. So over here, we're gonna do some questions. I want you guys to tell me, are these following 10 polygons simple polygons or are they complex polygons? Number one, you can tell me.
Simple.
Excellent. This is simple. Okay, number two.
Number 2, what do you think?
Complex.
Complex. Excellent.
Complex.
Excellent. How about number three? Now it's getting tricky. Now it's getting tricky. Number three, simple or complex? Take a guess. Take a guess.
Simple.
Anyone? Simple. Pam, pam, pam. Excellent. Simple. Why is it not complex? It looks very complex, like a complex shape, but there's no line that is crossing. You see, even the shape looks funny, but no line is crossing. This is also a concave polygon. It has two angles pointing inside, so it's a concave polygon, but still simple. Okay, how about number 4?
Complex.
Complex. Why? Because look at all these little points here where the lines are crossing and going through each other. You can see them all here, making it complex. So you can see it's basically like a rhombus with 4 triangles attached. Totally complex. Excellent. Number 5.
Complex.
Complex, are you sure?
Yes.
Okay, let's write it down. Let's see. Anyone else have an answer? Complex or simple? Who can tell me? Anyone else? Oh, pam, para, pam, 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 pam. Yay, this is 100% correct. Because look here, they are crossing. The lines are crossing, going through here and going through there. Complex if they cross. What about number 6?
Simple.
Yes, excellent, excellent. Very simple. Number 7. Number 7.
Simple.
Simple. Excellent, excellent. What about number 8? Number 8, you can tell me. Simple or complex?
Simple.
Excellent, excellent. Simple. Number 9.
Complex.
Number 9 is another complex one. Excellent. Why? Because we can see the crossing of the lines. How about the last one, number 10? Tan, ta, 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 is
Simple.
simple. Excellent, excellent. So this is just a short example, a short questions of how to identify or classify each polygon. But in this exercise, we only looked at simple and complex. So we didn't look at any of the other 4, which is okay. We don't have to do all of them every time. As long as we know the rules, we are okay. So when we're talking about polygons, we also have to sometimes calculate the angles. And there's a very simple formula we can use to calculate the interior angles. So this is to calculate the angles on the inside of the polygon. So if this is my polygon over here, I want to calculate what is the size of all the angles, so I can answer the questions that the teacher will ask. So, very simple formula. What is the main thing we have to start doing now at this age when doing mathematics? We have to start learning formulas. Because the more mathematics we do, it's going to become more based on formulas. So every calculation has rules. And to calculate this rule, we have to use this formula. Like we calculated the perimeter of triangles, we have to use a different formula or a different method. So the one thing that we are going to do a lot of is formulas when we do mathematics, especially when we get to the older schooling grades. If you get to the maximum level, yes, mathematics becomes more based on formula. And can you understand the formula? So very simple. Our formula is n minus 2 times 180. What are we going to do? What are we going to do? How do we do that? What does n even mean? Does n mean a night out with the friends? Does n mean a nice time? Does n mean anything? What does it mean? In this instance, you will see a lot of formulas that use letters. For example, n. The most important thing you have to do, read what n is for. What does n stand for? So here, reading becomes also very important, because in this formula, I will show you in the book if I have that page here. Yes, in this formula, they tell us over here, the sum of all interior angles equals n minus 2 times 180 degrees. Now, n represents the number of sides. So if you look at this one over here, the number of sides. So you can write there to yourself in your book in big bold colors. Oh, let me change the color here. Big beautiful bold colors. N equals number of sides. Very important, because if you don't know what n stands for, how are you going to solve the problem? I don't know. It's not possible. So now we know the formula. Yes, yes, yes. Can we use it? Let's test it. Let's test it. Oh, getting so excited with mathematics. Ooh, you guys seem so sleepy. Come, let's get excited. It's Monday. So the reason this formula is the way it is, I'm not going to explain why they write the formula like this. It's very complex, the way they figured out how to calculate. So let's just look at an example and then use the formula to test it. So over here, I wrote down an example. A triangle is a three-sided polygon. Calculate the size of each angle and the total of all interior angles. So for this example, I would say this is a equilateral triangle. Equilateral triangle, meaning all sides and angles are the same. I do this so that it's just easier for us to do the example. So the formula, very first thing we write down when you answer, you first write the formula. So here at the bottom, I wrote the formula for you. Remember to always show the teacher what you are doing. And writing the formula shows the teacher you understand. Yes. So n minus 2. Number of sides. Triangle has how many sides? You can tell me.
3.
3. So we're going to take the 3 over here. Here's my pen. We're going to minus 2. Sorry, let me just get this. We're going to minus 2 and times by 180. So 3 minus 2 is 1. 1 times 180 is 180. So all the side interior angles, the sizes of them add up to 180. So if we want to calculate one side, you take the total 180 divide by the number of sides, 3. So 180 divided by 3 will give us 60 degrees for each side. Okay. So we'll do some exercises on this because I want us to practice it so we can understand it beautifully. Okay. And please, if you don't understand, you can always contact me in the chat while we are having the class, or you can contact me on my line as well. You can find me on the line group. You can just add me as a friend and ask me your question there if you want to ask some questions, if you are a bit shy to ask in class. I like if you ask in class because then everyone gets the chance to do the answer. So, okay, this page I'm going to skip. I don't care about this page. This is the one I want to focus on. So if you get lost or get stuck, remember you don't have this page in your book, but this page is also almost the same as this one, just a little bit easier to read. So here they also give us the formula and 2 examples. Now I'll skip the examples. I'm tired of examples. I want to calculate what's going to happen. So number 1, example, triangle. We just did it. 3 sides. Sum of interior, 180. Each angle, this is the one I want us to do for homework, this page. Each angle, we already said it's 180. The total, remember, the total divide by the side. So 180 divide by this one, divide 3, equal 60. Okay, so 4, if we have 4 sides over here, what do you think is the sum of the interior angles if we don't have the 360? It's very simple. 4 number of side minus 2 times 180. Remember to first do the minus, put in brackets, important, equals 180. Equals 2 times 180. It's going to equal 360. Do you agree? Yes or no?
Yes.
Yes. Okay, very good. Very good. So now we have the 360. How do we calculate each angle? So let me show you how I want you to write the answers when you complete this schedule. We're going to do, we'll do this one at the bottom as well. So from this, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll do 3 with you. The one we have, the nonagon, we'll look at that. And then the top 2. So your answer will be like this. The first thing you write is n minus 2 times 180. Oh no, sorry. I'm in the wrong page, in the wrong place. For this one, you write n minus 2 times 180. And then you do the rest. Calculate. For the middle block, you take your total 360 divide by 4, the number of sides, because we want the size of each. So 360 divided by 4 will give us 90 degrees each side. Now have a look at your quadrilateral over here. Look at the angles here. Do you see these are all right angles? 90, 90, 90, 90. So it makes sense that our answer is 90 degrees. We can have a look. The one thing we should also understand is the more sides we have, the larger the angles become. The more sides we have, the larger the angles become. So for example, if you look at a pentagon, each angle will be about 108 degrees. Okay. So how much time do we have left? 4 minutes or so. Oh, excellent. So page 43, I want you guys to complete for me. Page 43. So teacher will already give you 2 answers. What do you say? Thank you, teacher. But I can't give you all the answers. I want to do one more example with you before we finish. And this is for the nonagon, the one with 9 sides. So let's write our formula first here. N minus 2 times 180 degrees. So this is going to be 9 minus 2. This is 9. Let's make sure you can read. 9 minus 2 times 180. So 7 times 180 equals 1260 degrees. Okay, so this is for nonagons. So now we have the 1260 divide by 9. And let's do it quickly. 1260 divide by 9. So 9 goes into 12 once. 1 times 9 is 9. Give me 36. 9 divided by 36 equals 4. Is 36. So 0. Bring down this 0. Don't forget your 0. 9 divided by 0 equals 0. So it's 140 degrees. Let's make sure that is the correct answer. Go back here. 140 degrees. Okay. So I remove the rest of the answers now. Hopefully you can calculate them. So first, number of sides. Second, each angle size. And third, total of all interior sides. Okay. These ones, perimeters. Okay, perimeters we're not going to look at today. We look at that in the next time. So just page 43, you can complete and please send it to the line group. Also, if you have any question, please ask the questions. Don't be shy. There's no such thing as a bad question. Every question I will answer. And if you don't understand, I will explain and try and find some way for you to understand. Okay. But if you want to know, please ask. Don't be shy. You can ask anytime. We are here to teach you guys, and we are here to benefit you. So use our information and knowledge where you can. Okay. So we have a quick 30 seconds to play some rock, paper, scissors. If you guys are in the mood, please turn on your cameras and please be excited, because if you want to beat the teacher, you have to be brave, because teacher is very good, you know. Teacher don't like to lose. So let's see who can be the one to beat teacher. In 5 seconds, we can do it. So get ready, get ready, get ready. On 4, 1, 2, 3, 4. Oh, it's only bonus and teacher Pooh that beat me. Congratulations, bonus. Yay. Good job, everyone. Thank you guys for playing. Some of you draw, some of you lose. Maybe next time you can beat the teacher. So next time I'll give you another opportunity. But for today, that is all. I hope you guys have an amazing day, and I'll see you guys again soon. Bye-bye.
Bye bye. See you on Friday.
Goodbye.